Morning. In today's lesson, it's like an extension for the previous lesson, but today we are going to speak briefly about the graphs and how to deduce the equation from the graph also. Here is a table that represents the height and base of a parallelogram where it's always the area is equal to 48 centimeters squared. When I say area, it means that I am multiplying the sides together, which is height and base. Since I'm using multiplication, so it's inverse of a proportional relationship. So A is equal to base times height, where A is always equal to 48. So BH is equal to 48. If I want to get H as a subject, so H is equal to 48 over B. So 48 divided by 4 is 12, 48 divided by 5 is 9.6, 48 divided by 6 is 8, and so on. Here is a real life example about the workers and their performance in the job. So it asked you just which graph shows the relationship. To know which graph shows the relationship, I have to know what's the relationship between the workers and the time performing a job. So what do we know is when the number of workers increases, the time in performing a job decreases. So it's inversely proportional to each other. As we took before in part 1, inversely relationship has a curved shape graph, which is not part A, of course, it's part C. Check if this relation is inversely proportional or not. So to check it, you have to multiply the variables together. So when you multiply each column 0.5 times 240, 1 times 120, and so on, you are going to discover that the product is always 120. This 120 is the constant of proportionality, which means that I can discover its equation. It's always giving you 120. Let's go to another way to discover it using a graph. So let's plot these points on a graph and read the graph. If you are going to say what's the speed taken by 1 hour, you will just take this line and check that 1 hour is 120. So 1 times 120 is 120. 2 hours, 2 times 60 is 120 also. 4 times 30 is 120 also. So I check that this is an inverse relationship but using a graph. What's the equation? It's S times T equals to 120. I'm going to summarize everything that we took in this slide. So which one of these graphs represent an inverse operation? Which one do you think? Yeah, exactly. It's number 4. By the way, number 1 is a direct proportion because it's a straight line passing through the origin. Now let's look at this graph. A is inverse proportion to B. So when he tells you inverse proportion, I have to conclude that when I multiply x and y, I'm getting the same product. So to deduce its equation, I have to take an easy point. All of these points are not easy to calculate because they have decimals. So let me choose the easiest point, which is 1. And it's connected to 1. So 1 times 1 is 1. So the equation is AB equal 1 or XY equals 1 or any variable. Now tell whether the graphs are inversely proportional and write its equation. Let's check this graph. First, you have to multiply the variables. Here the variables x and y. Let's multiply x and y of each point. 2 times 12, 24. 4 times 6, 24. 6 times 4 is also 24. 8 times 3 is 24. Every time they are giving us the same product. So it's inversely proportional. And the equation is xy equals to 24. Now, let's take this graph. Let's check. Take any 2 points. For example, let's take 5 and 10. 5 times 10 is 50. Let's check the other point. Do they have the same product? 2 and 25. Oh, it's also 50. So they are inversely proportional to each other, and the equation is x y equals to 50. As a reminder, we have to say that not all the graphs having curved shapes are inversely proportional to each other. We will discuss this idea in the next lesson. And here is your homework for today. Thank you for listening.